Question 11. Find the distance between point X and Y measured along the equator. Example. So there are 2 points X and Y. They have same latitude but different longitude. So the distance between X and Y is horizontal distance. Distance XY is, this is the difference between longitude, 10 degree west and 35 degree west. This is the formula for horizontal distance. It means we find the difference between the longitude multiplied by 60 and multiplied by cos latitude. So the distance is 1500 nautical miles. So for exercise A, we find the difference between the longitude. So 160 minus 45 and then multiplied by 60 and then multiplied by cos 0 degree. So the distance is 6900 nautical miles. Exercise B. So the difference between the angle is 45 plus 30. And then we change to nautical miles. So we need to multiply by 60 and then multiply by cos 0 degree, and we get 4500 nautical miles. Exercise C. The difference in longitude 25 plus 45. Then change to nautical miles times 60 times cos 0 degree, and we get 4200 nautical miles. C and D are 2 points on the surface of the Earth. Find the longitude of D. Example, D is located 3000 nautical miles due east of C. So the longitude of D is, so this center means the east of C is D. Let's say this is point C. So the east of C is point D. And the distance between C and D is 3000 nautical miles. And then we change it into angle. So 3000 divided by 60 times cos the latitude 0 degree. So the difference between C and D is 50 degree. For C is 15 degree east, and then the difference is 50 degree. So for D is 15 plus 50. So we get 65 degree east. Exercise A. So the west of C is D. So let's say this is point C. The west of C is point D. The distance between C and D is 4500 nautical miles. Then we change it into angle. 4500 divided by 60 times cos the latitude 0 degree, and we get 75 degree. Only the horizontal distance we need to time cos. Is vertical distance we don't need to time cos latitude. So for C is 30 degree west, and then the difference is 75 degree. So for D should be 30 plus 75 degree. And so longitude of D is 105 degree west. Plus because here is west, we go to left still west. Exercise B. The east of C is D. So let's say this is point C. So east of C is D. Distance CD is 1500 nautical miles. Change it to angle. Divided by 60 times cos latitude, cos 0 degree, and we get 25 degree. So for C is 15 degree west. Here is west. We go to the right. For right side, this direction is east. So to get the longitude of D, we use 25 degree minus 15 degree, and we get 10 degree east. A and B are 2 points on the surface of the Earth. Find the shortest distance between A and B measured along a parallel of latitude. So you can see they have the same latitude and the difference in longitude. So this is the horizontal distance. We can use the formula. The difference in longitude times 60 times cos latitude. Latitude means the 10 degree. So the difference in longitude is 5 minus 40. When same direction, we minus. And then times 60 times cos 10 degree, and we get 1477 nautical miles. Exercise A, use the same formula, difference in longitude. Both are west, so same direction. Big angle minus small angle. Then times 60 times cos the latitude 50. So we get 1350 nautical miles. Exercise B, use the same formula. The difference in longitude, east and west, different directions, so we add both angles. Times 60, cos the latitude 30. So we get 2078 nautical miles. Exercise C, same formulas, difference in longitude, west and east, different directions, so add both angles. Times 60, and then times cos latitude 20 degree, so we get 3608 nautical miles. P and Q are 2 points on the surface of the Earth. Given the distance between P and Q measured along a parallel of latitude, find the longitude of Q. Example, Q is situated 2100 nautical miles due east of P, and we find the longitude of Q. Let's say this is point P, so the east of P is Q, so this is point Q, and the distance is 2100 nautical miles. We change it to angle, so divided by 60 times cos the latitude, cos 60, and we get 70 degree. So for P is 15 degree west, difference is 70 degree, so the longitude of Q is 70 minus 15, and we get 55 degree east. Exercise A, let's say this is point P. The west of P is Q, so this is point Q, and the distance is 2400 nautical miles. Change it to angle, divided by 60 times cos latitude 20 degree, and we get 42.57 degree. So the longitude of P is 15 degree west. The difference is 42.57 degree. So the longitude of Q is 15 plus 42.57 degree, and we get 45.57 degree west. Exercise B, let's say this is point P. The east of P is Q. The distance is 3000 nautical miles. Change it to angle, divided by 60 times cos the latitude, cos 53 degree, and we get 83.08 degree. So the longitude of P is 80 degree east. The difference is 83.08 degree. So the longitude of Q is 80 plus 83.08, and we get 163.08 degree east. Exercise C, let's say this is point P. The east of P is Q. The distance is 900 nautical miles. Change it to angle, divided by 60 times cos the latitude, and we get 23.34 degree. And for longitude of P is 120 degree west. The difference is 23.34 degree. So the longitude of Q should be 120 degree minus 23.34, and we get 96.66 degree west. P and Q are 2 points on the surface on the Earth. Find the shortest distance between P and Q. Example, P and Q can be shown in this diagram. We see the difference in longitude is 120 plus 60 means 180 degree. It is so far. The shorter distance should be from Q, go to South Pole, and then go to P. From P to South Pole, the difference in longitude is 90 degree, because from equator to South Pole is 90 degree. And from equator to P is 45 degrees. So we need to find this angle. So 90 minus 45, and we get 45 degrees. And the angle from Q to South Pole is, from here to here is 30 degrees, and from equator to South Pole is 90 degrees. So the angle from here to South Pole is 90 minus 30, and we get 60 degrees. So the total distance is 60 degrees plus 45 degrees. Then we times 60 to change it into nautical miles. So the shorter distance is 6,300 nautical miles. Exercise A. This is the shortest distance. From P to S, the angle is, from equator to P is 20 degrees. From equator to South Pole is 90 degrees. So the total angle from P to S is 110 degrees. And the angle from S to South Pole is 90 degrees minus 65 degrees, and we get 25 degrees. So the total distance from P to Q is, and then times 60 to change to nautical miles. So the distance is 8,100 nautical miles. Exercise B. Let's say this is point P, and so this is point Q, and they have the same longitude. So we just need to find the vertical distance. To find the vertical distance, we just need to find the different angles. They have different directions, so we add both angles and then times 60. And we get 3,300 nautical miles. Exercise C. Let's say this is point P, and so this is point Q. They have the same longitude, so we only need to find the vertical distance. So the vertical distance, they have different direction, so they add both angles and then times 60, so we get 7,200 nautical miles.